discussion which we are going to have will also deal with safe transportation and disposal. This is becoming a very big issue. I mean, industries are looking for a solution, and let me tell you one thing, that the whole concept of conventional geotechnical engineering is changing, or it has changed, or I am the major culprit. The way I tormented the entire subject, I do not know whether good or bad, but yes, I am seeing that a lot of applications are there in the market. And I am sure you must have realized after visiting the laboratory that something non-conventional is happening there. And because we get a lot of support from the industry, most of the research is funded by the industries, and we have a very strong relationship with the industry, because environmental geomechanics cannot be done in isolation. It's just like a relationship between a doctor and a patient. So, unless the patient is there, doctors cannot do anything, and if doctors are not there, patients cannot do anything. All right. So, very soon you will realize that I will be creating a lot of situations where you will realize that this relationship between patient and the doctors is very much applicable to this, and what you are talking about material characterization, my logic is that this is just like your pathological examination. So, this is how I treat that. So, we will talk about transportation and disposal, which most of the industries are facing as a big challenge in today's world, and development of suitable strategy for proper utilization of the waste. And this is where our group has also coined this concept of man-made soils. I forgot to mention Dr. Naveen Koshi at IIT Jammu. So, he is also offering this course. So, the issue is quite big. I hope you are realizing is transportation, disposal, handling to utilization and converting into some value added product, which we call as valorization. We will talk about that. So, apart from a discussion on these issues, this course also highlights the importance and relevance of revising the basic concepts of geotechnical engineering. This course is basically meant for PG students. A lot of students, undergraduates also want to do this course, but you know what is the meaning of the word blasphemy? You must have come across. Yes. So, what is blasphemy? Exactly. So, this is what I am going to do here now. So, this is what, please remember, apart from a discussion on these issues, this course highlights the importance and relevance of revising the basic concepts. It is in a very humble and polite way of writing that this is what we are going to do. We are going to bulldoze the concepts of conventional geomechanics. Why? They have become obsolete. You can't use them for solving the real life problems, as simple as that. So, when you realize that the code of conduct is not helping you in solving a problem, what would be your initiative? What will be doing? Either change yourself or change the Bible, which was written by whom and when and why is not clear. You understand? That is the reason that why this course is meant strictly for PG students, because you already have the background of basic soil mechanics, and I expect that you can play easily with the concepts and you can change them the way you want, so as to deal with the concerns raised by these issues. Very big issue, line. So, what it indicates is that unless you change yourself, unless you change the course of conducts which have been defined in the books, you can't go ahead. So, the situation is like this, that we know that we are handicapped. We can't apply the equations which have been given in 1940s, 1950s by our great researchers. All right. So, and why all this is being done? So that we can get the best answer to the questions. So, in addition to this, the course focuses on pointing out the role and importance of the parameters and mechanisms that govern interaction of contaminants with geomaterials. So, interaction is going to be a key word. Everywhere interaction. When I am talking to you, I said it's not teaching, it's interaction. When you talk to me, it's an interaction. it is not a question. So, interaction is something which most of the technologists talk about. How many types of interactions you have come across in geomechanics? Any idea? Yes?
We only dealt with the three-phase relationship, and most of our
Interactions. Yeah, give it to him. Yes,
soil-water interaction.
very good. One is soil water interaction. Number 2, yeah, give it to her.
Soil structure interaction.
Very nice. Soil structure interaction. Third one, soil interaction. Correct. Fourth, any guess? Create new interactions. So, most of the time you have talked about solids interacting with the liquids. In petroleum industry, it's solids, liquids and gases interacting with each other. So, there nobody is interested in doing hydraulic conductivity of a porous media. Why? They are more interested in, let us say, gas permeability of the porous media, because they are producing gas. So, they want to know how much volume of the gas passes through the porous media in a certain amount of time. So, this becomes your gas solid interaction. The more complex situation would be, you have fluid, you have gaseous form, crude oil coming out of a well, and the whole mechanism is taking place in the porous system. Clear? So, this becomes liquid, solid, gas interface, the interaction between all the three phases of the matter. Is this fine? So, we are going to talk about how this interaction takes place, interaction between one entity and another entity, gases interacting with solids, solids interacting with water, gases interacting with water. So, until now you have talked about only pore water pressures, is it not? Very conveniently you remove the term pore gas pressure. Why? You saturated everything before testing. That is not the justice done with the material. Nowhere in nature we have saturated soils. If that was the situation, country would not have been crying for water. Agreed? So, you have been studying a state of the material which is artificially created by you, oversimplified. This is part clear? I can see a lot of heads nodding. Is this okay? So, the first premise that you are talking about the states of the materials which are hypothetical, utopian, they are not real. We will discuss this more and more. Clear? So, the interaction of contaminant with the geomaterials and their degradation. In our conventional subject, we are always talking about the control volumes. We never bothered about the degradation. Hope is correct. When you are doing seepage analysis, you took a control volume, and the control volume never deforms, never distorts, never degrades, everything remains intact as if it is made up of steel. Even steel also degrades, but your porous media never degrades. All right, clear? The second thing is consolidation theory. Again, you talked about the control volumes, and you said influx, outflux, I am balancing the two. The material remains as it is. Of course, it shrinks or swells depending upon the load conditions. But in real life, it is not going to happen. In real life, the material degrades. Why? I just cited an example of organic systems. So, most of the soils might be having some organic content in them, and this organic matter is going to degrade. Is this fine? Another good example of this would be MSWs, municipal solid waste, where the whole idea is to let the material degrade. If it remains as it is of no use. Clear? So, all this degradation, either this could be natural or this could be in the presence of chemicals or radionuclides. So, radionuclides are coming out of a very specific situation, which is when you are handling radioactive materials, ores, when you are processing them, all right, nuclear power stations, weaponries where you are making weapons. And I know in today's context, I hope all of you will agree that every nation would like to do this, because every nation wants to become a powerful nation. G5, G9, G12, all those clubs are there. No? So, you want to join a club or not? G5. So, India is trying to become a club member of G5. I hope you understand the connotation of this. What is G5? What is G9? What is G12? And so on. Now, this type of situation may also occur when we are dealing with the temperatures, because industrial waste comes out at elevated temperatures. So, how these temperatures are going to influence the whole system, the porous media, the geomaterials, and so on. So, the scope is becoming quite big, I am sure you must be realizing, but more realistic. Is this okay? Are you convinced? Any questions? So, however, as contaminant geometrical interaction is an extremely slow and complex process. Why? Because the permeabilities are extremely low of the porous system, which primarily depends upon their physical, chemical and mineralogical properties. It is quite difficult to study this interaction under laboratory or in situ conditions, because process is extremely slow. The fluid phase migration is extremely slow process. Hydraulic conductivities of clays are 10⁻11 meter per second. Even sands would be 10⁻6, 10⁻7 meter per second. When you talk about the rocks, 10⁻21 meter per second, but the interaction is occurring. So, a big challenge is whatever is happening in nature, how would you simulate it? How would you study this? How would you see what would be the detrimental effect of this interaction? So, this is becoming a challenging situation. In other words, whatever happens in nature, would it be possible for me to simulate in the realistic manner, either numerically or experimentally in the laboratory? Is this part okay? So, all these are going to be challenges. So, this calls for different types of modeling techniques. I do not know how many types of modeling techniques you have been exposed to. There is something known as accelerated physical modeling. I am sure you must be doing a course on this centrifuge modeling this semester. No, next semester you will be doing good. So, this what is accelerated physical modeling, centrifuge modeling. We can use FEM, finite difference, numerical modeling, analytical analysis and so on, all right. So, these are mathematical models which you develop for the situations. Sometimes the concept which has been ignored is that how physical, chemical and mineralogical properties might get changed when all these situations which we have discussed some time back become pertinent. So, I was talking about temperatures, and then I said the system might change its characteristics. I was talking about the type of contaminants which might be so aggressive that they may have a tendency to eat up the porous media. Clear? That means the all overall properties of the porous system are bound to change because of this interaction. Unfortunately, this type of discussion we have not done in conventional geomechanics. Is this okay? So, this is what actually we will be doing more and more into here. So, the contents of this course were mostly developed by my students activities, in the form of my PhD students and the master's students. So, what I try to do is I try to share what has been done by them in this context since several years. And in the process we have developed the laboratory which you visited, and you have already physically seen this, but those of you who have not, you can visit the website and you can go to this link. What is your observation after visiting the lab? What comes to your mind after seeing this lab? Environmental Geotechnology laboratory. Yes.
This is our very first time for this lab, so we have lots of equipments, lots of different machines or apparatus we'll see there, and different workings they explained us, and all other experiments. And we
What
also
comes to your mind? Typical and critical one. All this anybody can see.
actually
I don't need 10 of you to see what everybody can see. Is this correct? So, what others cannot see and what you have seen, I want to hear.
gas hydrate
Hmm.
instrument, which is very unique there.
Hmm.
So I'm very excited to work on with that also. So this is very something like
No,
exciting.
forget about the instruments and all. I mean, like you go to a place and you saw something. So, what comes to your mind? Don't get attached to the innate things.
And it's different from the conventional geomechanics lab.
In what way?
That some of the environment related, just for example, muffle furnace and different environmental means the acidic and basic characteristics we were measuring in that instrument, and so these were not found in the geomechanics lab. So it's in relation combination to the environmental lab and geotechnical lab. So
Okay. Next.
It looked more like CSC and mechanical lab than civil engineering lab. Like we used to see like civil engineering lab like a triaxial machine or CTM or UTM, but we have seen more of like computational applications to the civil department. Like we have seen automatic direct shear test with freezing equipment, also double wall triaxial apparatus, or we have seen that measuring of porosity by directly machine. So it's not more of physical, it's more of automated, like computational applications are there.
Okay.
It's different from the other conventional labs. Here, most of the instruments are to stimulate the actual conditions, like the double walled triaxial test or the mercury intrusion, pore master, all those we are trying to like do the actually how it is in the field rather than taking like
Okay.
assuming it to be saturated, things like that.
Okay. You are not there. Yeah, please. Next.
Actually, we saw many instruments which were advanced version of what we have seen till BTech. Like we were not able to find those below 75 micron. So there we found sieve below 75 micron.
Up to what level? Up to what
to
size?
20 micron. Up to 20 micron.
20 microns.
20.
Okay.
Okay, then.
Dry sieving.
No, vibration.
Yeah, but dry sieving, is it not? Yeah.
Dry. Then more. We can. There were many instruments that have that were related in. I can say like real inside in situ conditions for giving that much of pressure, whichever means for example in that gas hydrant it should be there with that pressure only. So there are equipments for providing that much pressure, like that. New instruments for bringing real in situ conditions.
Okay.
So the main thing that attracted me in that lab was that separation of hydrates, gas hydrate and soil. One can was a steel can with lots of bolts were there. That was the main thing which I was so much curious about, and some questions came to my mind after seeing that thing, which I left to ask.
Yeah. So what are those questions?
Like they told that
I can attempt to answer. Yeah.
Yeah. Okay. They told that they asked us a question that how you will know that the gas hydrate and soil got separated. That's an opaque can. You can't see from outside. So, and we were unable to answer. They have told us that it's by measuring impedance of the thing.
Okay.
But my question is that like how is the impedance of gas hydrates less than or greater than that of soil? I didn't.
See, the most important thing which all of you have missed out in after this tour to the lab is that your emphasis is mostly on instrument. And believe me, 80% to 90% instruments were not purchased, they were developed.
Told that it is made.
So, come out of this concept of instrument and gadgets doing anything for you. It's unfortunate that people think unless you have the instrument and the gadget, you can't do anything. Because even the gas hydrate setup which you are talking about is fabricated by us, and the fabricator is in Germany. That's a different thing. So, most of these instruments were created by, it's a philosophy again. I want to do this, and the size of the sample would be this, and the pressure would be this, and temperature would be this, and the humidity would be this. I want to see the surface features and so on. So, even the laser microscope has been prompted by us to the developer that we would require something like this, so that we can see the material properly. So, what I wanted to check is that could you catch this pulse or not? That most of the things have been tailor made. They were not available off the shelf. So, that is the requirement. So, when you come across a situation where you want to say x plus y equal to z, how would you prove this? You have to assume some value of x, assume some value of y, and see whether z is corresponding to this or not. Clear? So, there is a lot of trial and error. So, most of the time you will see when I discuss in this course, and this is what I have written, that most of the findings of my ex students I present over here, because this is how the course has got developed. So mostly this is the PhD theses and master's theses which were thematic, and those themes are becoming the modules to environmental geomechanics. This is what actually I wanted to emphasize. It's okay. And there was no way we could have ordered the instrument directly. 2-3 things: instrument might not be available, instrument might be very expensive, which we can't afford, and another thing is when students work on a thesis, you should have easy access to the setup. You can't wait for 2 years for the instrument to come. By that time the thesis would be over.